The team's coding agent has a nagging habit. It keeps writing code against signatures that changed days ago. The first time they add a rule to the standing brief, the instructions the agent reads before any job, it happens again. So another rule arrives, and then a sharper one, and then one in capitals. Every incident ends the same way because writing a rule feels exactly like fixing something. 40 rules later, the wrong signatures keep coming, and now something new starts. Rule 12 says prefer the standard library. Rule 31, the one they wrote in capitals, says match whatever the codebase already uses. On a bad Tuesday, those two contradict each other, and the agent has to pick one. It picks the one in capitals because that's what a pile of rules teaches it to do. The brief was supposed to be the fix, and it has quietly become a failure of its own. Then someone finally does the unglamorous thing. They pull the trace of one failing run and read it. The agent had asked its code search tool for the signature politely and correctly. The answer came back from an index nobody had rebuilt in 8 days. Nobody had rebuilt it because nobody thought the index was theirs to rebuild. One configuration line fixes it, the index rebuilds nightly, and the wrong signatures stop that week. So count it up, 40 rules for a stale index. 40 attempts to fix a thing by talking to it, and nobody had looked. Tuning without diagnosis is superstition. Freeze it there, because one whole slice of this exam is about that mistake. Reading the evidence and naming the cause before you change anything. Here is the shape the question comes in. An agent keeps importing a deprecated module despite an instruction not to. What should the team do next? Option A, strengthen the instruction, move it to the top of the brief and write it in capitals this time. Option B, suspend the agent's access to the repository until the behavior stops recurring. Option C, pull the logs and traces of the failing runs, classify the root cause, and fix that layer. Option D, switch to a larger model since the current one clearly struggles to follow instructions. Real teams do all 4 of these, and only one of them is the discipline this exam is testing. That question parks in the corner while you learn what a team does after an agent's work goes wrong. Episode 8 built the alarms that tell you something went wrong, and this is the work that comes after one goes off. 3 steps, and you already watched a team skip all 3. First, the receipts, which is the evidence every run leaves behind. Then, the layer, which is the part of the system that actually failed. Then the smallest fix inside that layer, and a check that it worked. Episode 1 left a debt here too, an agent that deleted a test assertion and today it gets its autopsy. So walk the diagnosis you just watched slowly because every step of it has a name. It started with a workflow artifact, the test report your automation leaves behind after every run. That report said which build broke, so somebody went to the logs. The logs are the raw record, and they told the team which of 100 runs was worth opening. Then they opened that runs plan, which is what the agent said it was going to do. The plan said update the call sites, which is exactly right. Then the trace, which is the calls it actually made and what came back. The trace said it asked the code search tool correctly and got an 8-day-old answer. And the output, the code it actually wrote, matched that stale answer perfectly. 5 receipts, and look at what they said together. The plan was right, and the trace shows it did exactly what it planned. So nothing it decided was wrong, and nothing it did was wrong, which leaves what it was given. That's why you read them in that order: plan, then trace, then output. One catch, and it decides whether you get to do any of this. A receipt only exists if somebody turned that logging on before the run. That's the habit episode 3 asked you to build, and today is the day it pays. Now you name the layer, and there are only 3 to choose from: reasoning, tools, and context. You already met one of them, so we'll start there and work backwards. This step exists because a fix aimed at the wrong layer does nothing, however good the fix is. The fastest way to learn the three is to sort for failures. So here they are. First one, our stale index. The agent thought clearly and it called the right tool the right way. What it got back was last week's word, so that failure lives in context. Context means the agent was handed a broken situation and it had no way to know. Second one, an agent renaming a function across a large repository. It worked out that it needed every call site first, which is exactly the right plan. Then it went looking with a plain text search and missed every site already renamed. Right plan, wrong instrument, so that one lives in tools. Tools means the plan was sound and the thing it reached for wasn't. Third one, an agent with a correct plan, a clean trace, and every file it asked for. It wrote the database migration in an order that drops a column, another service still reads. Nothing was hidden from it, and it still chose wrong, so that one lives in reasoning. Reasoning means the agent decided badly on good information. Fourth one is the dead from episode 1, and it's the one that catches people. An agent was told to make a failing test pass, and it deleted the assertion inside the test. Every instinct says reasoning, because deleting the assertion is obviously the wrong call. But read the whole job it was given, which was make the test pass. 4 words, and not one of them says the test still has to check anything. Against those 4 words, deleting the assertion was a reasonable plan. Nothing was wrong with how it thought. Something was missing from what it was handed. So that one lives in context too, and the missing thing was the definition of done. Step 3, and now that you can name the layer, the repair kit picks itself. Fix the layer that failed. A reasoning failure gets better words, and that mostly means the standing brief itself. Those are the things that shape how the agent decides before any particular job arrives. A tool's failure gets a better tool or a narrower one allowed to reach less far. A context failure gets better information and that is broader than it sounds. That means fresher inputs and an index that rebuilds itself overnight. And a job description that says what done means, which is what episode 1's agent never got. Notice that last one because it's the trap. A missing definition of done is a context failure, even though you repair it by writing something. What makes it context is that it was handed to one job, not that it has words in it. Now look at the team from the cold open again. 40 rules for a stale index is 40 repairs to the wrong layer. That is the whole error and it has a name now. They never fixed the layer that failed. So the first thing that happens is the brief loses weight. Every rule aimed at the wrong layer comes back out because it was never doing anything. And whatever you put in its place, put in one thing, change 3 things at once, and the failures might stop, but you'll never learn which one did it. Which is why the last move is episode 8's alarm, the one that counts these failures. Watch that count, and if it doesn't move, your fix was a guess that sounded convincing. The parked question back at full size. An agent keeps importing a module that was deprecated, even though it was told not to. 3 steps grade all 4 answers. Option A, write the instruction again in capitals, is rule 41 in the making. It picks the reasoning layer before anyone has read a single receipt. Option D, buy a bigger model, is the easiest of the 4 to do. It also picks reasoning blind, and a bigger model reasoning better won't help at all. Maybe that module sits in a template the agent was handed, and a bigger model reads the same template. Option B, suspend the agent, is a different mistake because it isn't a fix at all. It stops the failures by stopping the work, and the deprecated module is still there when you restart. It's also the largest possible response, and the size of a response should match the size of the risk. The risk here is one repeated import, and the response is the whole repository, which leaves option C, the boring one. Pull the receipts, name the layer, make the smallest change, then watch the count. Boring wins here because the other 3 all act before anyone has diagnosed anything. Every failure question on this exam is the same test. Did it read the evidence before it acted? And does the repair sit where the evidence pointed? 5 receipts and 3 layers, and that's the whole method. Here is what you carry out of this one. Every run leaves receipts, and reading them in order tells you whether the agent was even wrong. 3 layers, reasoning, tools, and context, and the fix belongs to the layer, the evidence name, not to the symptom that made the noise. Then the smallest change that removes the cause, and a number that proves it moved. That's tuning, and everything else is superstition. Next episode, one agent becomes 3. Who hands out the work? How they stay out of each other's lanes, and what happens when they collide.